All right, in this video, I'm going to go over finding the average rate of change from a graph or a table. Now, let's start with graphs. And let's assume that the scale here is 1 unit of measure per tick mark. Okay? And they're asking us to find the average rate of change on the interval -1 to 2. So in order to do this, we need to know and understand interval notation, right? Going from -1, including -1, all the way to 2. Now, this is talking about the x values. It's talking about the input values, okay? Now, average rate of change will be the change in the y values over the change in the x values, or delta y over delta x. So, what is delta y? It is the y value of the point at -1. This would be our x1 value, and this would be our x2 value, okay? That is very important. You need to know which is your first x value and which is your second x value so that you know x sub 2 minus x sub 1. Because in subtraction, order matters. You need to make sure that x sub 2 goes before x sub 1. So what do we have here? Well, we know the denominator. We have 2 is our x2, right? So x2 comes first, minus -1. x1 is our -1. I put in parentheses because whenever I substitute, I always put parentheses just to make sure that I don't get confused about those signs. Double negative is going to be a positive. All right. What are our y values? Well, we need the graph for that. What is our y value at x equals -1? 2, 3, 4, 4, right? Right there. Yeah, that's where it lines up with the -1. Of course, my drawings aren't perfect, but this isn't a drawing video. This is math. So -1 would be our y2 value would be 4. And it's going to be subtracted from our y2 value. Y1 value is going to be subtracted from the y2 value. All right, so what about 2? That would be at y equals 1. Okay, so we have this point here, 2 comma 1, and this point here, -1 comma 4. Those are the 2 points we're dealing with, and we just kind of put their values in, and we do the math. 1 minus 4, -3, over 2 minus -1, or doof doof, 2 plus 1 is 3. -3 over 3 is -1, right? And that is your average rate of change over the interval -1 to 2, okay? Now, just to demonstrate how order matters, let's find the average rate of change in the same graph from 2 to -1. Oh, accidentally did parentheses there. Okay. 2 to -1. Okay. Well, it's the same thing, right? Just swapped. This is our x1 value, and this is our x2 value. And our y values are still 4 and 1, but it's going to be 4 minus 1 instead of 1 minus 4 here. Okay. 4 minus 1 is 3. -1 minus 2, -3. Now we still get the same answer. But that was because once I flipped them, I still did everything right. See, what if I had gotten confused and did 1 minus 4? Then it would be positive 1, you see? So you got to make sure that the order lines up all the time. All right, let's do... I also want to point something out here. You might realize that this kind of looks familiar. This whole formula that we've been using to find the average rate of change, it's because what we're doing is we're finding the slope. We're using 2 points to find the slope of a line that's joining those 2 points. What if we went from 0 to 3? What would we get then? At 0, we get 1, right? So 0, 1 is our first point. And at 3, we get to 4. All the way up to 4 there. There. Okay. y2 minus y1. 4 minus 1. x2 minus x1. 3 minus 0. Equals 3 over 3. Just positive 1. You know why? Because it makes a perfect x. we just went from just, 2 units over from the origin point on that side to just 1, and from 1 unit over on this side to 2. So we kind of just found the slope of that line there. That makes an x. What if we went from negative 1 to 1? Okay, well, negative 1, 4 is a point, and 1, 0 is the other point. y2 minus y1, x2 minus x1. Negative 4 over 1 plus 1 is 2, negative 2. So we're just finding the slope of that line that connects those 2 points. That's all we're doing. And these two lines here are perpendicular. Why? Because they're negative reciprocals of each other. The reciprocal of 1 is just 1. So suppose that's why they might skip this part in some math classes. It's because you kind of have already done it, and when you found the slope of a line just using 2 points. But it helps to know that the rate of change is just another way of saying slope, right? Average rate of change. It's just slope. It's just with a line, that rate of change is constant. It's both the average and the actual rate of change throughout the whole thing. In a graph like this, a parabola, that rate of change is constantly changing. It gets real low, and then it gets real fast again. If we were graphing someone's speed as they were driving, they would have slowed down to stop at the red light, and then when the light turned green, they sped up again. All right, we found the average rate of change along a graph, using a graph. Now let's talk about using a table to find the average rate of change. Now, this table is based on the miles away from home a person was during a road trip. Now, they started at 10 miles away from home because they had to pick up their friend. And the road trip didn't start until their friend was picked up and were ready to go. So they're already, at time 0 hours, we're already 10 miles away from home. Now, we're taking quite a big trip, quite a long trip. So going for 7 hours. But there are stops along the way and speed limits change. And so not always sure what the average rate of change is. But I notice how I accidentally said speed there for a second. That is what we get when we find the slope of the lines connecting these 2 points, like I was explaining before. The slope is the rise over run, right? So the rise would be the y values, or in this case dt, or d of t, which is miles, right? Over, that's the rise, over the run, which is t, hours. So when you find the slope or the rate of change, you get miles per hour. Makes sense, right? Okay, so we're asked to find the average speed of this whole trip from 0 hours to 7. Okay? Now, what was their distance at 0 hours? It was 10, right? Distance at 7 was 310. Again, order matters. x2 minus x1, y2 minus y1. 310 minus 10, that's pretty easy math. 7 minus 0, that's even easier. 7. 300 divided by 7, that's not easy math. I did that on purpose because not all the math is going to come out nice and clean. So let's just do some long division here. Just review it, just in case you were getting rusty. How many times does 7 go into 30? It can't go into 3. So we go to 30, right? So 7 times 4 is 28, right? 2 remainder. Bring down the 0. 7 goes into 20 only 2 times. There's our decimal. 20 minus 14 is 6, right? Bring down another 0. 7 goes into 68 times. We can round up from there, right? So we'll say approximately 43 miles per hour is our answer to part A. That is the average speed that our driver was going for their 7-hour trip once they picked up their friend. Okay. What about part B? We just want the average rate of speed from the first hour to the 3rd hour, from the end of the 1st hour to the end of the 3rd hour, if that makes more sense to you. 3 minus 1, right? 153 minus 65. Right? Okay. Denominator is easy enough. 153 minus 65. I can't do this math in my head. 13 minus 5 is 8, right? 14 minus 6 is another 8. 88 miles per hour. Okay. 88 divided by 2 is 44 miles per hour. Wow, they were going pretty much their average speed through those 2 hours there. Oh, 3 hours. Is it 2 hours? I'm getting confused. From the end of hour 1 to the end of hour 3. So 1, 2, 2 hours. Okay. That is what tells us how many hours have passed, is the difference there. Not a good day for math. All right, part C. They just want to know from the 3rd hour to the 4th hour. That should be easy. There's only 1 hour there that went by. But it seems to be that they covered the greatest distance in that hour, looks like. Only like 42 miles there and 28 miles there, maybe. No, I'm crazy. 38 miles there. No, yeah, 28 miles. I don't know. That's 28 miles. Anyways, this seems to be our biggest jump in distance. So let's see. 4 minus 3 is 1, obviously. 214 minus 153. Okay. 214 minus 153. Oh, carry the 1. 61 miles an hour. And we're definitely on the interstate for that.